It may take time to process. It really depends on which instrument we're talking about and the size of the object. Just last week, it does come from some sort of extraterrestrial intelligence that was beaming out radio signals for everyone who's been following the 3i Atlas mystery. Buckle up, because what happened this week has left even the most skeptical scientists stunned. On November 2nd, the European Southern Observatory confirmed something that shouldn't be possible. The interstellar object known as 3i Atlas just changed speed without losing a single gram of detectable mass. That's not a typo. The object literally accelerated in open space, with no visible jets, no debris, and no measurable outgassing. According to ALMA's spectral readings, it jumped roughly 0.16 meters per second, a tiny number on paper, but a seismic one in astrophysics. Because, under Newton's laws, you don't get acceleration without an external force. And yet, that's exactly what we're seeing. This latest data came right after its perihelion pass, when 3i Atlas was closest to the Sun, about 74 million kilometers away. Normally, a comet flares, burns off ice, and loses measurable material as radiation pressure pushes it outward. Instead, Atlas did the opposite. It brightened, but didn't shed mass. It accelerated, but didn't produce a tail. The readings don't fit any model, not a comet, not an asteroid, not even the interstellar debris we've cataloged before. And this isn't a calibration glitch. 3 independent observatories in Chile, Hawaii, and Spain confirmed the same positional offset 4 arcseconds off its predicted path. That might sound microscopic, but in cosmic mechanics, that's huge. To put it simply, something out there pushed 3i Atlas and no one can explain what. Harvard astrophysicist Avi Loeb, who's been tracking this object since its discovery, called the event an anomaly that violates known cometary dynamics. He's cautious, of course, but even he admits this could mark the first recorded case of an interstellar object behaving as if guided by something other than gravity. It's not proof of technology, not yet, but it's not random either, because every time we point a telescope at 3i Atlas, it refuses to act like anything nature would build. And this might only be the beginning. The first anomaly revealed itself quietly hidden inside data, so subtle most observatories would have brushed it off. When analysts compared 3i Atlas's orbital path from October to November, one pattern stood out. The object was drifting against the pull of the Sunday. Under normal physics, that's impossible. Gravity should be tightening its curve, pulling it inward like a stone around a whirlpool. But Atlas was doing the opposite, nudging outward, defying the star that should be controlling its motion. At first, researchers blamed instrument drift, but then came the confirmation. Chile, Hawaii, and La Palma all recorded the same deviation 4 arcseconds from the model path. That's not a measurement error, that's movement. And then came the color shift. During its closest approach, Atlas didn't redden like dust-rich comets do. It turned blue, bluer than the sun itself in certain spectra. ALMA's ultraviolet readings showed a sharp intensity spike, meaning the object was reflecting light in ways no known natural material should. A comet's brightness curve normally follows a clean arc, heating, venting, fading. Atlas's curve broke that rule. It flared, dimmed, then flared again, as if powered by something pulsing beneath its surface. Here's the part that has scientists pacing their offices. If this acceleration were caused by gas venting, Atlas should have lost around 5 billion tons of mass, and enough to form a vast debris cloud. But the James Webb Space Telescope saw nothing. No dust, no plume, no scatter pattern. Avi Loeb described the data as non-gravitational propulsion without exhaust, a phrase that doesn't belong in astrophysics textbooks. And yet, that's exactly what's unobserved. Every line of data points toward a force unaccounted for, something beyond solar radiation, gravity, or magnetism. A hidden engine? A reactive surface? No theory fits. If these readings hold as Atlas nears Earth in late December, we may be staring at the first confirmed case of a self-accelerating interstellar object. When scientists started dissecting the data, they didn't just find one strange pattern, they found 9, each one more improbable than the last. The first was its path, retrograde, moving against the planet's direction, yet perfectly aligned within 5 degrees of the solar system's ecliptic plane. The odds of that happening naturally? About 2 in 1,000. Next came its structure. 3i Atlas isn't small. It's roughly 1,000,000 times more massive than Oumuamua and 1,000 times larger than Borisov, the two interstellar visitors we thought had redefined our limits. But Atlas dwarfs them both, and it moves faster. In nature, that combination doesn't exist. Bigger objects slow down as they conserve momentum, like comparing a truck to a motorcycle. Atlas breaks that law with ease. And then came anomaly number 3, the anti-tail. Between July and August, the object developed a jet of vapor pointing toward the Sunday. That's the opposite of what every comet ever observed has done. Solar radiation should push tails away, but this one fired straight into the light as if resisting it. Spectroscopy revealed something even stranger. Atlas's surface contains a metallic alloy with an unusually high nickel-to-iron ratio. No natural comet or asteroid has ever shown that mix. It's eerily close to industrial-grade alloys forged in furnaces here on Earth. The probability of finding that ratio in a primordial interstellar body? Less than 1 in 100. And when the water content was measured, the surprise deepened only 4% by mass. That's not a dirty snowball, that's an iceberg made of rock. Piece by piece, the data was forming a picture no one wanted to see. A massive, fast, metal-rich object, traveling on a mathematically precise path, behaving as though it's steered. Even skeptics are running out of explanations. Because every new reading breaks another rule. All roads now lead to one date, December 19th, 2025. That's when 3i Atlas will pass closer to Earth than it ever has before, skimming just outside our planet's orbital window. For astronomers, it's not just another flyby, it's Judgment Day. If Atlas truly lost mass during its acceleration, there should be a massive halo of debris following it, billions of tons of dust, rock, and vaporized metal glittering in its wake. We should see it easily through the James Webb Telescope, even from halfway across the solar system. But if no cloud is found, we'll face what researchers are quietly calling the 10th anomaly, an object that accelerates without losing mass. That's not a mystery, that's a violation. It breaks Newton. It breaks relativity. It breaks everything we think we know about how matter behaves in a gravitational field. The European Space Agency has already scheduled synchronized observations using ALMA, Webb, and SOHO, hoping to triangulate every photon this thing throws off. Even a faint trace of expelled gas could save the standard model. But so far, nothing. Not a shimmer, not a flicker. Avi Loeb and his team at Harvard are preparing contingency papers, coup versions of the same report. One if the debris appears, one if it doesn't. He calls it a coin toss for cosmic history. Because the truth is brutal in its simplicity. If the cloud exists, Atlas is just a hyperactive comet with weird chemistry. If it doesn't, something entirely new is crossing our skies, a body powered by physics we don't yet understand. And that's why December 19th isn't just another date on a telescope log. It's a line in the sand between what we believe the universe is and what it might actually be. In the weeks leading up to December 19th, tension has turned into obsession. Across observatories in Chile, Arizona, and Japan, astronomers are taking shifts in near-constant darkness, waiting for 3i Atlas to cross their scopes. They know this moment could redefine cosmic history or expose a glitch that science can't fix. Internal memos from the European Space Agency leaked online last week, revealing that at least 2 optical arrays detected a secondary reflection pattern, trailing Atlas by a few hundred kilometers. The signal flickered in rhythm like a pulse. Some say it's just a tumbling fragment. Others whisper it could be modulation, the kind produced by rotation or by control. NASA isn't commenting publicly, but insiders confirm their deep space network has logged coherent radio drift from the object's direction frequencies that shouldn't exist in the natural background. The readings are faint, inconsistent, but real. Meanwhile, Harvard's Avi Loeb continues to balance skepticism with awe. In a televised panel, he said, "If nature can build something this precise, it means we've underestimated her intelligence by 1,000-fold. If it isn't nature, then we're witnessing engineering on a scale we've never conceived." The debate has split the scientific community in two. One side argues for exotic physics, radiation recoil, magnetic repulsion, or quantum tunneling effects. The other side refuses to dismiss the idea of technology, even if technology means something that's been drifting between stars for eons, running on autopilot, waiting to be found. But one thing everyone agrees on: the data is flawless. The instruments are verified, the acceleration is real. In a field where even micrometers can spark wars of interpretation, 3i Atlas is the first object to force silence, not because we know what it is, but because we don't. December 19th arrived, and with it, the closest approach of 3i Atlas. For 48 hours, telescopes around the world locked onto a single target, drifting through the dark like a silent messenger from another age. The data came in waves, each one stranger than the last. First came the light curve. Instead of a steady fade as it passed Earth's orbit, Atlas pulsed rhythmic brightening, then dimming, repeating every 6 minutes. The pattern was too precise to be random, yet too subtle to call a signal. It was like watching the heartbeat of something ancient, mechanical, and alive all at once. Then came the spectrum shift. At exactly 0320 Universal Time, Atlas emitted a brief ultraviolet flare, 1,000 times shorter than a second, that bent incoming solar radiation instead of reflecting it. No natural material known to science can do that. Theories collapsed overnight. By dawn, even skeptics had gone silent. The predicted debris cloud? Still missing. No dust, no gas, just the object. Accelerating again, slightly faster now. Still without mass loss, still without explanation. Avi Loeb published a short statement, only 6 words long. We are witnessing something beyond physics. And perhaps he's right. Because whether Atlas is a machine, a relic, or a new class of cosmic phenomenon, it's rewriting what we thought was possible. Every telescope that watched it tonight recorded history, a moment when the universe looked back at us and broke its own rules. Now, as it fades into the outer dark, the question isn't what pushed it, but why. Was it chance? A test? A message? Whatever the answer, 3i Atlas has already changed us. And when it returns, if it ever does, the world will be ready.